Hi everyone, my name is Federico Maggi. I'm a researcher with Trend Micro, and in this series of videos I'm going to show you how to think as an attacker when you deploy a smart factory environment or smart manufacturing environment, which will help you make sure that you reduce your cybersecurity risks. So OT environments or operational technology environments are indeed a very attractive target, as we have shown in multiple ways in this report that we have released on May 11th. What I'm going to do with this series of videos is to walk you through the paper essentially. So I'm going to first show you how a smart manufacturing system works. And then I'm going to show you two ways that an attacker can use to enter this system. So attack vectors that you may or may not have thought of. And then we'll see what can happen if there is a mobile HMI, which is kind of a innovative or futuristic human-machine interface, and what kind of risks these devices bring in. And then we will conclude by showing you finally what an attacker can do once they are inside your system. So let's go and take a look at the paper. Here is how a smart manufacturing system works. This is what we have used in this research. It's an installation at Politecnico di Milano University. And although it's a deductive environment, it has the same components and it's assembled with the same standards of a real system. Just to give you an overview of the plant, it has 7/8 stations, if you consider the conveyor belt as a station as well. It produces toy cell phones. There are at least 3 components, 2 parts that make the case of the phone. Then there is an internal PCB, printed circuit board, and then there is the other part of the case that goes on top. So the production starts over here in the loader. You can think of it as a magazine containing the first part of the case of the phone, and then the conveyor belt brings the first part in the assembly, which basically aligns them for continuing the production, and then passes over to the driller that drills holes, of course, and then goes into a closed cage where there is a robotic arm, like a classic industrial robotic arm, that takes the PCB from another loader and places into the case along with some electronic components. And then the resulting product goes back onto the conveyor belt for visual inspection. There is a camera here with an automated software that makes sure that the parts are aligned properly. Then another assembly step that takes the second part of the phone case, and then the press that closes the 2 parts, snap them together to create the final phone essentially. And then the resulting product goes back into the conveyor belt for the operator to pick it up. All of this is controlled by a so-called MES system, which is a sort of you can think of it as a small SCADA system, but is optimized for production environment as opposed to classic ICS. And I just wanted to show you how the screen of an MES looks like. This is what we had in the lab. And it is essentially an order manager. So every production order is a series of steps that each of the components, such as a PLC and the machines, have to go through. And the MES makes sure that all the parts, all the components of the system receives the order in the right at the right timing, and that there are enough resources into the loaders of the parts, for example. And it keeps this aligned with the database of the ERP, Enterprise Resource Planning. So if there is any supplies to order, the MES will notify the ERP, and then somebody will take action, right? So let's go back again on the paper. because I wanted to show you one last but very important part, which is the engineering workstation. The engineering workstation is a sort of the orchestrator of all of this. It's not really orchestrator, is like the behind the scenes machine, in the sense that all of the programming, all of the automation that takes place when the system runs is written offline by human, by somebody, by an automation engineer. And a lot of this programming is happening on this machine, the engineering workstation. The engineering workstation is just a computer with lots of industrial automation software installed, and that is used by engineers to write scripts or to do testing before deploying a program written by somebody else. It's a sort of a gateway, if you want, not really gateway in a networking meaning, but a gateway from a software perspective. So if there is a new software upgrade or a firmware upgrade to apply on the PLCs or any of these components, that will have to go through the engineering workstation most of it. What do we want to do with this system now that we have this system? What was the purpose of our research? We wanted to answer a few key questions. First of all, we wanted to understand under which conditions, so we wanted to do classic attack and threat modeling, under which conditions an attack can take place. Of course, simple and traditional IT attacks such as a ransomware also work in these environments, because anyway, they have classic IT systems. So if, for example, the MES gets infected or the engineering workstation gets infected, well, in those cases, the production may very well stop anyway. So classic IT attacks also work here. We were more interested in non-IT attacks or OT specific attacks that can leverage the technology that is deployed here. So the specific software that runs here and the logic and so on. Another question is there any overlooked attack vector, something that we haven't thought of at the beginning that may be a good opportunity for current or future attackers, something that we haven't thought if we keep thinking of these systems with a pure IT perspective. So malware, of course, or phishing emails, of course, are valid alternatives, but we wanted to look at something more technology specific, right? Another question is, what is the impact on the security risk of the modern software development practices, which may include complex libraries, open libraries downloaded by different sources? If you take a look at the paper here, and you will notice that among the devices there is so-called custom IIoT device, right? Which is nothing more than an embedded system with a custom firmware on it. And this firmware is developed by somebody who is either a system integrator or maybe even an employee of the factory. And in that case, the sources of the software, the sources of the libraries are a very key component that an attacker might very well target. And on this last question, I'm going to close. Please make sure that you stay tuned for more upcoming videos. And if you want to take a look at the details, here's the paper. Take a note of the title and just Google for it. You'll find it on Trimicro website. Thanks for watching.